Hello everyone, today we're going to be talking about experimental probability. So last time we talked about finding a theoretical probability, and a theoretical probability is when all outcomes are equally likely. And so we can find the theoretical probability of an event by taking the number of favorable outcomes divided by the total number of outcomes. Experimental probability, on the other hand, this is based on repeated trials of a probability experiment. And so here, the number of trials is just the number of times the probability experiment is performed. So let's say the probability experiment is seeing the probability of landing on heads if you flip a coin. So the number of trials would be the amount of times that we flip that coin. And then a success is each trial in which a favorable outcome is achieved. And so in that one, it would be every time we land on head, that would be a success. And so the experimental probability then is the number of successes divided by the number of trials. And so here we can end up seeing a difference between experimental probability and theoretical probability. So looking at the same example of flipping a coin, when you're looking at the theoretical probability, you had a 50% chance of landing on heads. But let's say when we do a probability experiment, let's say we flip the coin 4 times and we land on heads, 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 and then tails. Here, my experimental probability being my number of successes, which is 3, over my number of trials, which is 4. So this would be a 75% chance, where the theoretical probability told you that you had a 50% chance. So we can end up with a discrepancy there just based on theoretical, if you're looking at logically what your probability is based on actually doing an experiment and finding that percentage. So let's go through some examples. In these first two, we're just going to be looking at finding an experimental probability. So number 1 says, in the United States, a survey of 2,184 adults ages 18 and over found that 1,328 of them have at least one pet. The types of pets these adults have are shown in the figure. What is the probability that a pet-owning adult chosen at random has a dog? So we're looking at the experimental probability, so I know that that is going to be the number of successes divided by the number of trials. So I want to see what my number of successes are first. Well, looking over at this chart, I'm looking to see how many chosen at random have a dog. And so I see in my chart there, that bar is there, so it's dog, and that's going to be 916 adults. And then I want to divide that by the number of trials. So I need to see what my total number is. There's a couple of different ways you can do it. You could go ahead and add all of the numbers you see here, or you can see what they surveyed. And so this one's a little bit tricky. They say they surveyed 2,184 adults. However, they found that 1,328 of them have at least one pet. And so we're looking at the probability that a pet-owning adult chosen at random has a dog. So that's going to be the 13,200 or 1,328 is going to be my total. So now I can use that to find my probability. So I have that the probability that a pet-owning adult has a dog is equal to the number of successes, 916, divided by the number of trials, which is 1,328. And when I divide those two numbers, you're going to get approximately 0.690. And so changing that to a percent, that means that the probability that a pet-owning adult chosen at random has a dog is about 69%. Okay, let's look at another one. So here it says the table shows the results of a spinner experiment. Find each experimental probability. First, I want to find the probability of spinning a tube. So I want to look at the number of successes. So I have this table, and it says the number that I spin, 1 through 4, and then the occurrences, so how many times I spin that number. And so I'm looking at spinning a 2, and so I see that that happens 13 times. And then I want to divide it by the total number of trials. And so I have all of these total occurrences for each number, so I can find the total by adding all of those up. So when I do 7 plus 13, I get 20, and then 20 plus 17, get 37, plus 11, and you get 48. So I'm going to have 13 divided by 48. And so when I divide those, I get approximately 0.271. And so that means I have a 27.1% chance of spinning a 2. I'm looking at the experimental probability. Now this next one, it says I want to see the probability of spinning a number less than 3. So I want the probability spinning less than 3. So now I need to see what the number of successes are. So what is the number of trials where you spun less than 3? And so I see that happens with this 7 right here and 2. Those are both less than 3. And so that means 7 plus 13, I have 20 occurrences where you spun less than 3, and you want to divide that by your total 48. So I have 20 divided by 48, and rounding that, you get approximately 0.417. And so that means you have a 41.7% chance.